2,955?
Yeah.
And how many million are we going to do that by?
5.
5 million. All right. Hey folks, welcome out there on this great afternoon, or perhaps some of you are joining me online. I'm Ernie Roberts, and this is Mathline. And many of you, I said, joining us online, YouTube, we've got you going, all right? And some of you are seeing us, as I said, right here live on the air. So thanks for tuning in. We appreciate you. It is test prep time with specialized segments. So, well, what does that mean? We're going to be looking at things that help you with EOCs, oh goodness, ACTs, SATs, just skills, rudimentary factors on the high school level probably, but some of you middle schoolers enjoy getting ahead of game, so tune in also. Get you some paper, get you some pencil. We're going to have a good time today, and you know what? We still got some of our friends from Bearden High School helping us out today. So sit back, relax, let's do some math. And let's see what this topic is today. Let us tell you a story. Oh my goodness, stories we could tell, and the stories we're going to tell you anyway, all right? Let's see, first of all, what's this about? It sounds like story problems to me, word problems, things of that nature. And once again, we've got the Bearden High kids along the way to help us out a little bit along the way. But we're going to look at applications to some of our math. So let's take a look at our first little story here and see what we've got.
Got a math question? Mathline has answers. Hey, Mathline.
Hey Mathline, this is Daniel from Bearden High in Knoxville. I have a percent problem for you. 64 is 40% of what number?
All right, Daniel, right off the bat from Bearden High School, thank you, my friend. 64 is 40% of what number? Now we look at this, and this could be probably, what do we want to say, camouflage might be a good word, or disguised, with a lot of other words, a lot of story. We're going right to the basics on this one, and Daniel will appreciate this question from you. But still, what do we do with percent? So many times we think we multiply and that's it. Well, let's check this one out, because 64 is 40% of what number? I've got a nice quick formula. It's a proportion. It's two ratios equaling each other, and it goes back to this. It's called the part over the base equaling percent over 100. And notice I've got an equals between there, so it's like two little ratios there equal. We make it a proportion. We call it that. So we're going to use that approach, and I want you to see the operations, all right, once we set through there. Because so many of you, when you go through and take an ACT test or an SAT or in a course, they've got these things called distractors, and they're going to go, if you do it the wrong way or do a wrong decimal or wrong this or wrong that, they're going to catch you, all right? They're going to have those answers waiting in the multiple choice. So let's see what we've got going on here. First of all, usually the base is where do you start? And according to this, 60 is 40% of what? Looks to me like the base is missing, all right? This is the situation where we're going to put a little X down there, and we're going to say 64 is where we end up. That's the part, basically the end of the story there, the part we're looking for. Do we know the percent? Yes, we do. And it always goes over 100. So really, there's your only worry is right here. Do you put the X in the numerator? You put the denominator? And again, think about it. The base is your starting point. Now, let's work through this thing and go find an answer, and we'll see how good it is. We're going to cross multiply. That's the game plan here. And when we cross multiply, we take X times 40, which is simply written as 40X. Isn't that nice? And on the other side, we've got what? 64 times 100, which we can do in our head. That's 6,400. Now, in just a second here, we'll see what happens when we put our calculator to work for us here. But right now, what we want to do is we're going to divide 40 into both sides here, all right? Into both sides, what we've got. And the X pops up by itself. Notice the zeros. One pair of zeros goes away, and if you can do a little mental math, it always helps. You can divide 4 into 64. It'll actually go 16 times, and let's see what that gives us. It looks like 160. It looks like 160. Now, we'll get a clear off here. Let's see if that worked on our calculator. All right, let's see if we did our mental math correctly. I got 6,400. We're going to divide by 40. And according to that, I get 160. We did well, didn't we, guys? Now, let's go one more step here. Let's see if we take, well, we got it, right? What we want to know, y'all really want to know? Let's see if 160, if we take 160, and now we're going to multiply by 40%. And folks, that's going to give us a 0.40 or a 40 hundredths, however, or 4/10, however you want to look at it, blah, blah. Here we are, 64 brings us back to where we started. So you can always easily check. That's what you got a calculator for. They do allow you to use calculators on EOCs, on parts of them anyway, and certainly on the ACT and SAT, those are quite good to be used. Now, Daniel said, just what he said, 64 is 40% of what number? Let's suppose we do something different, all right? Let's try this. Let's suppose that we decide to say, what is 40% of 64? Big difference there. So if you'll take me away here, guys, we got one waiting for us here. Thank you. All right, let's look at now. Now we got here. What is 40% of 64? Very good. Now we're going to do the same approach. This time, notice my base, my starting point is 64. And we're still going to put 40% over 100. We have 64 here, and then we have, this time we're looking for that part. We're looking for the ending result, so to speak. Now, storyline being 100x, it already looks different, doesn't it? And on this side, I am definitely going to swing over here for a calculator. We're going to go 64 times the 40, and we're going to multiply, and that gives me something kind of crazy. 2,560, we divide by 100. That means the decimal is moving 2 places. So we're going to have, let's divide by 100, both sides. That moves the decimal in 2 places. So we're going to have what? 25 and 6/10, or some of you like to call it 25.6. That's not a percent. You've already got your percent right there, okay? That's your percent. You already got your percent over 100. So this time, again, we're looking for the part, and there it is. Definitely different than 160. So folks, when you do a percent problem, be careful that you understand. Are you given the base or are you given the part? Which way are you going? And sometimes you may be looking for the percent. In fact, let's take a look at another problem and let's see where we have to find a percent. So it's a quick review. Daniel, you just opened up a whole realm of problems here. You know that when you ask your first one. Let's see what we got here. It says, what is the percent of increase if the item is raised from 75 to 90? So this time I'm already aware that I need to know what? I need to know what percent. So I'm going to call that my x. You say, well, Ernie, is everything else known? Everything else is known. Where did you start? What is your base? What is your base? Your base is at 75. Now what happened? We're looking for the percent of increase, not the percent of this new price, but what is the increase that got us to this new price? So how much did we go up? We went up 15. That is going to be our part in this problem. So now we've got it easy to look at. And we could go, my goodness, we could say 75 times x. Remember, we're going to cross multiply. And we're going to do the 15 times 100, which is going to give us 1,500. That's our cross multiplying. Divide both sides by 75, and this one really comes out nice. So 75 goes into 152 times and a 0 left over. So this is going to be 20, and this time it is a percent. It is percent. Well, you say, Ernie, how could we go back and figure that one and check it? Well, pretty easily. It's a division this time, isn't it? So another way you could do it, if you went through this approach, let's say on the calculator, let's go look at 15 divided by 75. And you get 2/10, 0.2, 0.20, 20 hundredths, however you want to look at that. But remember, it asks for what percent? That's not a percent. That's not 2/10 of a percent. What you want to do is move that decimal 2 places. So if we have something that looks like this as a percent, that is 20%, because you're going to move that decimal 2 places. So a key thing to remember, you got other ways to do the problem, but sometimes you got to make an adjustment. In this case, you do. You got to move the decimal 2 places to, looks like the right, and that'll give you the 20%. The same thing if you want to change 20% to a decimal, move it to the left 2 places, and you're in good shape. That's your percent lesson, real quick and short form here. So let's see what we got coming up here. We hit the percents, and those can be in so many different story things. You can be talking about how much money you're tipping, what percentage, if you're going to do 20%, what is the tip you would leave, things like that. So there's a lot of applications. So let's look at another type problem that involves thinking about rates and maybe even another proportion. Let's hear from Emily from Bearden High.
Hey Mathline, this is Emily from Bearden High School in Knoxville, Tennessee. My problem is a pool fills at a rate of 12 gallons a minute. What is the rate in gallons per hour?
Wow, rates, and rates. You know, all of our tests love rates in mathematics, it seems like. It's a big, big important concept. So we're going to take this pool filling at a rate of 12 gallons a minute, and now we want to translate that to gallons per hour. Now, the gallons are going to stay the same, but our units of time are changing. And this is one of those practical examples that probably would be hard to pigeonhole, but it's really kind of an algebraic thing. Some of you are going like, oh, I figured it out in common sense. Well, that's good. Let's play a little algebra, and then we'll look at the common sense also. And hopefully it makes sense on both rounds. So let's go back to proportion. We've been doing that with the percents. This one's not a percent situation, but we do have gallons per minute. We're going to make that in a fraction, okay? So we're going to take gallons, 12 gallons for, oh, how nice, 1 minute. Now the question is, how many gallons? We don't know. And we got 1 hour. Now, you don't want to put a 1 back down there. That won't make any sense, all right? What we've got to do is remember, oh yeah, got to remember how many minutes are in an hour. Well, that's not hard. We do that every day, right? Minutes, day, yeah. Oh, anyway. All right, so we're going to put a 60 in there because, like I said, on my planet, in my world, it's 60 minutes per hour. So, Emily, we're going to transpose that. We're going to transform. We're going to use proportion. And again, the cross multiply game. And this one's really sweet because we get x times 1, which is x. And here we go with 12 times 60. I know, some of you are saying, I think I know the answer, but maybe I don't. If you know your multiplication tables, you know 12 times 6 is 72. And then you got a 0 coming along for the ride. Yeah, isn't that true? 12 times 60 equals 72. Add a 0 before 720. Did the calculator know? Why not? Let's find out. Let's see what we've got. 12 times 60. And I see 720. So you see sometimes, folks, the mental math helps you save some time. Because every time you have to go to that calculator, it's distracting, number one, and it takes you out of the pace. When the ACT asks you to do 60 problems in 60 minutes, you need some stuff up here. That's why we have you try to learn a few things along the way so you don't look at going, what do I do now? What do I do now? There will be some problems like that, don't get me wrong. But most of the time, we want you to be able to look at and say, hey, that's easy. That we can do. I understand how to do that. Quick process. Maybe you need a calculator just to help your arithmetic. That's fine. But don't have to rely on it for every single little thing. Mental math. That's how you get those high ACT and SAT scores. You take a little less time than what you thought you had to do. Now, speaking of story problems, we had one there. Thank you, Emily. And now let's take a look at another one that's just kind of created for us here. It's about a rectangle. And it says a rectangle has a perimeter of 48 inches. Now let's first of all get something correct here. Perimeter is all the distance around. And by the way, how many sides does a rectangle have out there, everybody? Think, think, think. 4. It's right. It's a 4-sided figure. So we want to make sure when we're talking perimeter, we find some mechanism to make sure that we have all 4 sides used in this problem. Now, let's read the next part of it. It says 48 inches total. So let's look at it here and see the length is 3 less than twice its width. All right. So that kind of tells me, since the length is 3 less twice its width, I'm going to go for the feel that this is the longer piece. All right. Maybe wrong. That's okay. We'll put it together. We're going to call width W. Why not? And the length, it says, is 3 less than twice its width. Now, I've got to read that carefully. Twice its width is going to be 2W, and we're going to subtract 3. It's not 3 minus 2W. That's not what we're saying here. The than forces us to switch that order. So we say 2W or 2x, whatever you're using for your variable, minus the 3. Now remember what I said? Remember what I said? Everybody remembers what I said, right? You need to put a w there and a 2w minus 3 here because we got to remember to add all 4 pieces together. I see so many problems when students are going like, I got it set up, and then they forget about 2 widths and the 2 lengths. So be sure you put all those things in there. I think the picture's a great way to go. If they don't give you a picture, sketch one. You can write all over your little test booklet. They don't care. They really don't. Do what you need to do to get to the problem. Now, let's see what's going to happen here. I'm going to go with 2w. You know why I'm going to go with 2w? Because there's 2 of them, right? Then I'm going to go to plus 2 times my length, which is going to be 2 times 2w plus 3. Now, I know it's dangerous when we do something like this. Is it a plus or is it a minus? It's a minus. Y'all don't lose me there, all right? That's a big minus, big minus. I was ready to go with plus 3. But by the way, what do we get when we put it all together? We have equals 48. All right, so now that I've got it and blobbed it off to pieces, wow, let's see what's going to happen. We're going to need to distribute. That's what we got to do. Keep your 2w. Now, go and double that 2w. We'll get 4w. And don't forget, you got to distribute all the way through that parenthesis. And that's going to give you minus 6 equals 48. Now, I'm catching 6w minus 6 equals 48. Now, to save all that mess that I just put there, having it on the figure, some of you said, well, I already see there's 6 w's there. Excellent. Also, you see a negative 3 and a negative 3, or a minus 3 and a minus 3, and you get a minus 6, which is right there the same story. So make it easy on yourself. If it works for you, go for it. Now, simple algebra? All algebra is simple. Not really, but this is definitely going to count as simple. We want to get rid of the minus 6. We're going to add 6 both sides. That's going to leave me with 6w over here equaling to a 54. And I picked this one nicely because we want to divide out and get even nice sweet numbers, and we do. We have w equaling to 9. So here's my number 9. How about that? We can put a 9 up here. See what happens. 2 times 9, mental math once again. 18 minus 3, you get 15. So we got 2 numbers. So what do? Oh, we got to find the area. So we definitely need both of those dimensions, the length and the width. We're going to take 15 times 9, and those of you who want to go to the calculator, we'll go for you right now. Let's see what we got. 15 times 9, and I'm getting 135. Now, let me remind you, that would be square inches. Okay, so there you go. That is your area, and that's where you're going to end up. Now, you know, some of the distractors they might give you would be something like, oh, 15, 9, maybe some other crazy numbers. But what happens is you got to get both of those, and it comes up to 135. They might also take some other examples, since some of you are prone to not know what to do with that. Well, now you know. But supposedly some other ways that you can maybe get area of, 135, but you don't get that perimeter. Or you might take some different combinations to get a perimeter of 48 that will give you an area, but not 135 either. So in other words, there's some ways they can make distractors on these tests and questions. Don't be fooled, all right? You got the way to do it. Use your algebra, use your picture, and let it rock. Now, speaking of something kind of similar, let's do another story problem. Bearden High, what you got for me?
Hey Mathline, I'm Soraya from Bearden High School. I have a problem for you to work out, please. Jack's age is 6 years more than 4 times Elise's age, and their ages add up to 26. What are both their ages?
Right, so, wow. That's one of those things called an age problem. How about it? Age problems makes sense, doesn't it? Talking about their ages. So we've got Jack and Elise, and according to this, we don't know either age. So we've got to take our information. So let's call somebody X or A or N or whatever you want to use for your variable. I'm going to go with X. So let's see. Elise, I think you should be X. Why? Because I think you should be X. All right? This is a good starting point. Because what do we know about Jack? We know that Jack has an age that is what? 6 more than 4 times her age. So sounds like there's going to be a pretty good span. So we're going to have to quadruple or 4 times her age and then add 6. Makes sense? Everybody's with me? We don't know either, so we call it the same thing. You could put an A, you could put an N, whatever variable you want. Now, I do know something about their ages. They add up to equal, how about that, 26. How easy was that? Do you see what I just did? We're going to say x plus 4x plus 6 equals 26. The story is real simple. They're adding up their ages total, 26 together. We also know Jack is a pretty good bit older. He's 6 years more than even 4 times Elise's age. Now, on down the road, that story will not hold anymore, all right? Right now, for the age of 26, that's where we have it. So let's see what happens. We get 5x, because there's a 1 there, right? Don't make that careless mistake. Plus 6 equals 26. Keep with me. Subtract the 6 from both sides. How about it? Subtraction property of equality. And see what we've got after all that good stuff. I have 5x equaling, it looks like, 20. Soraya, I think we're going to get a nice even number, which was hopeful. Looks good. X is equal to 4. Now, we lose the bottom third there. We'll finish this off. X is 4. That's Elise. She is a young thing. Jack, on the other hand, is a good bit older, like I said he would be. Let's see, 4 times 4, because that's what 4x plus 6 says. So we'll take 4 times Elise's, which is 4 times 4. Add the 6. I'm getting 22. Are those good answers? Well, how do we know? Because 4 plus 22 gives us 26. The storylines will get you back if you'll just check when you get to the answers. The storylines will take you back and make sure that your solutions make sense. They work. They go together. Good enough? Hey, Soraya, thank you for that problem. And age. It's always a question mark here. Let's do one here for the road, all right? One more problem here, a little geometry moment here. It says a triangle with a perimeter of 75. That might be feet, might be inches, might be yards, just 75 we're saying here. Has lengths which are consecutive odd integers. Now there are 3 of them, right? It's a triangle, so there's 3 lengths. But look what we're asking here. Oh, they're trying to trip you up. They're trying to see if you read. Find the longest length of this triangle. So here's the story. Consecutive odd integers. How far apart are odd integers? They are 2 units apart. For example, 3, 5, 7. Maybe 10. No, 10's not odd, is it? So you already have in your mind that we've got to have an odd value for numbers here. So keep that in gear. You say, well, Ernie, is it any different if we were even doing even? Evens are also 2 units apart. No. So let's see how we're going to set this thing up. Our first side, I'm going to call it x. It looks kind of equilateral, doesn't it? It's really, there's somewhere a little bit of a grain of difference here. The next one is going to be x plus 2. Some of you said, well, it's odd. Don't you put x plus 1? No, we put x plus 2 because the next odd integer is 2 units away. And then we'll pick up one more here at x plus 4. Those are our 3 sides. Obviously, who's the longest? X plus 4. That makes sense? I hope it does. Because here we started with x, we added 2, and then we added 4. This guy's the biggest. So what does perimeter mean? We add our 3 pieces together. Add them right there. So let's go with it. X plus 2, x plus 4, and according to that, our perimeter is at 75. Well, that sounds pretty much like the rectangle problem, doesn't it? In many ways it is. You're still adding up all the sides of the figure. All right, in this case, it's a triangle. In that case, it was a 4-sided quadrilateral. If we had a pentagon, we'd be looking for 5. All right, you get the idea. So different pictures are always helpful, and this is really easy to see where you're going. Now I have an x and an x and an x. I don't still get an x. I get 3 of them now. So we have 3x. Let's add 6 to that. And my dear friends, we got 75 hanging on. See where we're going? It's an easy algebra at this point, isn't it? Oh, it's an easy algebra. Subtract that 6. We're going to do it. 3x. Over here, we're going to have 69. Nice about 69, 3 will divide into it evenly. That's the big thing. We want it to be evenly because it's an integer, right? It goes in there 23 times. Now, here comes the moment. We got 23 for x. And some of you go like, oh, there's the answer. I see 23 as one of my choices. No, it isn't the answer. It's what x equals. but we're looking for the longest, right? So over here we got 25 in the middle. Over here we got 27. My friends, first of all, if you add them all up, you get 75 units. So we're back. That checks the numbers. We know we're good. But what is the longest length? The longest length in this one will be your 27. So my caution is, here we got X, but sometimes X isn't the answer to the problem, all right? So again, read your story, see what it tells you. Tell us a story. We got a lot of great ones today. Hey, Bearden High School, thank you so much for being with us today. And the three of you are with us. They've got a few more times with Bearden. And also, if your school would like to help us out, please let us know. We'd love to have you on camera with us also. And folks, thanks for tuning in today. And thanks for tuning in online if you were there. Remember, Mathline Online, YouTube. We will see you again next time.